Okay, so welcome to my video on z-test versus t-test. And the reason why I'm making this video is because many of my students get confused on whether they should use a z-test or whether they should use a t-test. So I'm going to go over 3 different examples which should hopefully clear up any confusion. And in these 3 examples, I'm going to show you when you should use a z-test and when you should use a t-test. So let's get started right away. This first example says that the average test score for an entire school is equal to 75. So the average for the entire population of the school, or the population average, is equal to 75. And the population average is always written with the Greek letter mu. And it also says the average test score of the school is 75 with a standard deviation of 10. So the standard deviation for the entire school, or the entire population, is equal to 10. And the population standard deviation is always written with the Greek letter sigma, and that is equal to 10. So and it says, what is the probability that a sample of 5 students scored above an 80? So we have a random sample with a size of 5, so our total number in the sample, n, is equal to 5. And what is the probability that the random sample of 5 students scored above an 80? So the average for the sample is equal to 80, and we're trying to find the probability that that 5 students scored above an 80. So let's look at our conditions for using a t-test. So let's find out whether we should use a t-test or a z-test. Okay, and I wrote these 2 conditions for you in our previous video, so I'm sorry if this sounds a little repetitive. But our first condition is that the population standard deviation is unknown. And notice how our population standard deviation is known. We do know it. It's equal to 10. So our first condition for using a t-test is not met. Therefore, we cannot use a t-test. We're going to use a z-test. So for this example, we would use a z-test, and our formula for using our formula for z is equal to the average of the sample minus the average of the population, all divided by the population standard deviation divided by the square root of the sample size. And I'm not going to go over this example anymore, because just the point of this video is I just want you to know whether you should use a z-test or a t-test. So let's go over another example. Here it says the average test score for an entire school is 75. Okay, so our population average, once again, is equal to 75. And then it says the standard deviation of the sample of 40 students is 10. So we don't know the population standard deviation, we know the sample standard deviation. The sample standard deviation is equal to 10. So our sample standard deviation, which we write with the letter S, is equal to 10. And it also says that the random sample of 40 students. Okay, so we know that in our sample we have 40 students. So our sample size n is equal to 40 students. And once again, it's asking us what is the probability that the average test score of the sample is above 80. So our average for the sample is equal to 80, and we want to find the probability that it's above 80. So what test do we use? Do we use a t-test or do we use a z-test? So now what's our first condition again? Our first condition is that the population standard deviation is unknown. That condition is actually met because we don't actually know our population standard deviation. We were given our sample standard deviation, but we were never given our population standard deviation. So our first condition has been satisfied. Now let's look at our second condition. The sample size for using a t-test must be less than 30. And take a look at our sample. Notice how our sample size is above 30. It's equal to 40. So our condition number 2 was not met for using a t-test. So once again, we would still use a z-test. And our formula for z in this example would be the average of the sample minus the population average divided by the sample standard deviation all over the square root of the sample size. And once again, I'm not going to go over this example in more detail, because just the point of this video, once again, I just want you to know whether to use z or whether to use t. So let's go over one last example, and I think that should cover everything. And in this example, it says the average test score for an entire school is 75. So once again, our population average is equal to 75. We have a random sample of 9 students, so our sample size is equal to 9. And it also says the standard deviation for the sample is equal to 10. So the standard deviation of the sample. So our standard deviation of the sample, which is S, is equal to 10. And once again, it's asking us, what is the probability that the average for the sample is above 80? So our sample average is equal to 80. We want to find the probability that it's above 80. So let's see if both our conditions for using t have been met. Our condition number 1 is our population standard deviation unknown. Yes, we don't know what it is. We were given the sample standard deviation, but we were not given the population standard deviation. So our first condition was met. We do not know our population standard deviation. Let's see if our second condition has been met. Is our sample size less than 30? Our sample size is 9, so 9 is definitely less than 30. So our condition number 2 has also been met. So for this example, we would definitely use a t-test, since both our conditions have been met. And our formula for using t in this example would be the average of the sample minus the average of the population, all divided by the sample standard deviation all over the square root of the sample size. So I hope this gave you a better idea of when you should use t and when you should use z. In my next video, I will be talking about binomial distribution, so stay tuned for that. I hope you're enjoying these, and I will see you in my next one.